You are watching the Target 3.1 retest film. In this target, you will be demonstrating understanding about exponential functions, comparing situations and equations for exponential functions to those for linear functions. Remember that you should have a packet picked up. That packet will need to be fully completed in order for you to do any kind of retesting. So make sure that you complete that. I will actually do problems right in that packet. Well, let's get started with these problems. I'll take away all suspense. The three that I have up right now are all linear. We're going to take a look at what makes them linear in each format, and then we'll look at some exponentials and go back and forth and make sure you understand. So right away, hopefully in the graphs, you see that linear looks like a line, but the more important piece, looks like a straight line, sorry, but the more important piece is that you see that it has a constant rate of change. So and rate of change just means rise over run is at the same each time. So it goes up 3 and then right 1. And if you notice, it keeps going the same pattern, up 3 and right 1. So one reason that you can use on this is it says it goes up 3 and over 1 as a constant rate of change. So, and the same reason is for number 9. You can see that rate of change in the y variable. Notice all of these go up 3 each time. And that 3 happens when each of these goes up 1. So the ones over here are the rise again, and these are the run. So that up 3 and over 1 is shown in both of those situations. So the reason can be the same for each of these, and it's linear because there is a constant rate of change. Okay, and in the equation, it's a little different. In the equation, you're either going to see the x as an exponent or the x as a y equals mx plus b kind of deal. So the x is either going to be here, that's linear, which you see here, oops, here. And so this one's got to be linear because the x is not in the exponent. Okay, so ultimately it follows y equals mx plus b form. Okay, now that's different than if we look at the exponential ones. Notice that this one doesn't have a constant rate of change. Up 1, right 1, up 2, right 1, up 4, right 1, not a constant linear, constant rate of change. And the same is true in the table. This goes up 0.5, then all of a sudden it goes up 1, and up 2, and up 4. So the rate of change is different. So it's exponential. If you notice, the rate of change is actually in a pattern. Doubles each time. Exponential because for now there is no constant rate of change. Now we're going to find out in other parts of this class that there can be other things that don't have a constant rate of change, but for now, this is good. Okay, in the equation form, you're going to notice that it's not y equals mx plus b. It's not slope-intercept form. The x is actually in the exponent, so that's what makes it exponential. Because the x is in the exponent. There you have it. Okay, now word problems. So, well, let's recap real quick. Linear, y equals mx plus b, constant rate of change found in the graph and in the table. Whereas exponential, no constant rate of change is found here and here. And it's not in y equals mx plus b form or slope-intercept form. It's in the exponent. Okay, let's look at words. To do these, we're going to take a look at a table real quick, and you'll see the verbiage, the words that kind of go along with it. So Isabella has 6 eggs. So, and it says 4 more each day. So here's the number of days, here's the number of eggs. On day 0, she's got 6. After 1 day, she's going to have 10 because it goes up 4. After another day, she's going to have 14 because it goes up 4. And you notice that same pattern holds true as you go through. That should remind you of linear, that constant rate of change. Notice it says 4 more each day, whereas the dollar one, Kimberly has $400. So each year, so this is years and this is money. So $400 in a bank account pays 5% interest each year. So after 1 year, we can see that she's going to have, let's see, 400 times 1.05 because it goes up by 5%, 420 after 2 years. Multiply again by 1.05, 441. Okay, and we can tell right away, but let's do a third year. Times 1.05. That multiplier is 1.05 because it goes up 5% each year. $463 and some odd cents. Now, this compared to this, compared to this, compared to this does not have a constant rate of change. And this was a decimal, but still it's plus 22. You see that it goes up each time a small amount, but it's not constant. So that's what makes this exponential. And this one linear. Now, some things to look at in the words. If it says words like adding and subtracting, like 4 more or 4 less, you know, automatically it's going to be linear because that's the pattern that you're going to see in the table. Whereas if you're taking a percentage, that percentage is what you're multiplying by each day. And that percentage changes depending on what number you have in this column. So notice 20 and 21 and 22 are all different because it went up 5%. Well, 5% of what is currently there. So that's what makes it exponential. Usually every time you see a percentage, it's going to be exponential. So there you have it. That's how you tell apart linear and exponential in the 4 different forms that you're going to see. Remember, you have to finish the entire worksheet packet in order to retest and bring it back to us during lunch or before or after school if you need any more help to get that help.